Okay, so now we're going to talk about injection molding. Injection molding, if you are not familiar with it, if you're looking at something right now, you're probably looking at an injection molded component. They are everywhere. They are in every part of our daily life. The keys on your keyboard, the pieces to your phone, your mouse, your many of the tools you use, they all form some form of injection molding. Um, and it all starts with just plastic pellets. They are fed into the hopper here. Stealing this infographic from Thomas Keck from ResearchGate. But the granules are fed into the hopper, down into the feed zone of the screw. They are pushed along the screw by the screw motion, and they're mixed in the mixing zone and compressed in the compression zone. And there's heaters on here, and these heaters are kind of a misnomer because they don't really generate much of the heat. They're there for thermal regulation to make sure that the temperature stays where it's supposed to be. But most of the heat, most of the melting comes from the friction between the plastic pellets and the barrel and the screw. This is the screw, this is the barrel. And it's the friction that really melts that plastic. So then as the plastic melts, the screw retracts and you build up a valley of material right here, a little reservoir of material right here. When the time to inject, the screw rams forward, forcing that. There's a ring on here that keeps the material from going back up the screw, and the material is forced in, and then forced into the mold cavity through the sprue, and then the mold is cooled with water or heated in the case of some high temperature materials. And then once it's cooled or to a non-molten state, the mold is opened and the part is ejected. You generally want the part to stick to the moving half of the machine, which is the part that the material does not come in, because it has ejector bars on it and you can eject the part. And then the part is ejected and it falls, and then the whole process repeats over again. It is a very fast process. You can see cycle times in the seconds, like tens of seconds. You can also have very long cycle times for very large parts. It's all about how much plastic you're trying to cool down, because plastic does not like to transfer heat. That is the number one concern when you're injection molding, is transfer of heat, because plastic is an insulator, so it holds on to its heat. So one of the most important things in an injection mold design is waterline placement. Now, there's other things in there that keep you from putting water lines where you want to put them, but waterline placement is critical. So let's go on and design a part. We're going to use SOLIDWORKS 2022, and we're just going to do a default part. Hold on a second here. Sorry about that. My mouse was set to Creo instead of SOLIDWORKS. So we're just going to create a simple housing of some sort. Nothing real complex. We're just trying to show off the features, not really reinvent the wheel here. So we'll just make something like that. We'll give it some geometry to it. Oh, wrong button. It always goes harder whenever somebody's watching you. Okay. And we'll just make that 2 inches, 1 inch, 3 inches. And since we lost our concentric there, or our center line there, we'll just make that 0.5. So there, we're going to make it half an inch thick. Now we want to put some holes in it to mount to. Just want standard holes. Positions. So we'll just place some holes. Always constrain your things. Leads to so much happier times whenever you need to make modifications. Horizontal. Now I got those holes constrained. Through all, I don't really care what size they are. Okay, so now let's finish off the top of this. Add some fillets. So right now this is just a solid block. Half inch thick, not a good candidate for injection molding. You want minimal wall thickness for injection molding. But we're going to get to that. So we're going to add some radiuses. Let's make them too much. 1/4 of an inch, that'll work. And then we want a radius on the top. Oh, before we do that, let's draft this bad boy. Anybody know a way to do this without having to click every single face? That's been frustrating me in SolidWorks for quite some time. Give it 3 degrees of draft. There we go. Now you can see. So let's go to Mold Tools. Draft analysis. There we go. Our draft is all in that direction. So we're good. Now our holes should be drafted as well, so we'll go ahead and add some draft to those. Draft them from this side. Just 1 degree of draft on those. So now let's do draft analysis again. Oh, that's why, 1 degree. So we can see all those surfaces are red. All these surfaces are green, which means that's the split of the mold. So the green will become the cavity and the red will become the core, or the green will become the part where the plastics is injected, and the red will be the part that moves, that pushes the part off of the part. So now we'll do one more thing here. We will shell, and we'll make it 0.085, and we'll shell it. So now we have a small problem. As you can see, if you look at draft analysis again, these are in the wrong direction, so they'll get stuck. So we can't have that. So features, extruded base boss, convert. Convert, extrude, Draft outward. 1 degree. Oh. Up to surface. And we'll have to edit that sketch and grab our poles. There we go. Now if we go back to draft analysis, select that face, 1 degree, we are golden. So now there's one more thing. I want to go back before the shell and throw a fillet on that face and go back. There we go. Now we'll do ribs. Let me see what button. That's not it. Yeah, bear with me. I gotta remember what my buttons do. So let's just draw a rib from here to here, from here to here, 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 here. Ribs help add stiffness to your injection molded part. A lot of times when you see an injection molded part break, it's because it either didn't have ribbing or the ribbing wasn't in the right places. That's sufficient for our short case. Now we want to be, now the ribs should be 70% of wall thickness. So 0.05 would probably be good. And 1 degree. And there we go. Now we have ribs. Couldn't remember for a second. Now we could add radiuses to these corners, which actually we probably should. Maybe a 0.0625, so that looks perfect. The reason why I want to do this is because I want to add a place for an ejector pin, because these ribs will stick in the mold. So if we can have an ejector pin on them, they will be more likely to release. So let's just get one there, one there, one there, one there, one there. Oh. There, there, one there, and one here. This way I can have an ejector pin in all these locations. Functional, not exactly the prettiest thing you're going to do. But there we go. The only thing you do risk is you do risk the possibility of sink marks here in these radius locations. But which is a cosmetic defect that can cause injection molded parts to be rejected, but we're going to take that risk. So that's our part. In the next video, we'll step it out into Creo and design a mold for it.